Alright, so I wanted to record this video because I felt like the information that was provided in Hawks kind of assumed that you understood a couple pieces about this normal distribution. So you've seen it, I mean, if I go back to the website and and I cruise back through the help here, I mean, on the very first slide, there we go. On the very first slide right here, you've seen what I'm about to talk about, but there's not an explanation. There's no explanation of what this symbolism right here means and how we apply that. So that's what I want to kind of introduce to you real quickly and hopefully help you wrap your head around it. Alright, let me back there. There we go. No. There we go. So here's what I want to say. Let's go to standard. So when we're our standard normal distribution, here's some things that we know. In the standard normal distribution, the mean is right smack in the middle. And in the standard normal distribution, we go up 3 times. So the first time we go up, that will be 1. So, excuse me. That will be, to get there, we would take the mean plus 1 standard deviation. To go up again, we take the mean plus 2 standard deviations, and to go up one more time, that would be the mean plus 3 standard deviations. If we decide to go down, so this is above the mean, if we decide to go down, this would be the mean minus 1 standard deviation, this would be the mean minus 2 standard deviations, and this would be the mean minus 3 standard deviations. And this would be below the mean. Wow. I'm going to act like you guys didn't see me write the wrong spelling of that word. That would be below the mean. So what does that mean? That means that right here this is plus 1 standard deviation, this is plus 2 standard deviations, this is plus 3 standard deviations, this would be minus 1 standard deviation, minus 2 standard deviations, minus 3 standard deviations. And when you watch the video that Hawks Learning provides you for how to take data and to find its z-score and then plot it, what that means is that it's saying essentially that, okay, well, let's say that you have a problem where you had a z-score of negative 1.5. Well, that means that you go from the mean down 1.5. So that right there would be a z-score of negative 1.5. Or hypothetically, let's say we had another one, like a z-score of 2.25. So you would go up 1, 2, and then you would say, okay, well, that's halfway. So then there's a quarter. And so that right there would be z equals 2.25. So remember, if you go up, it's positive. If you go down, it's negative. Let's see what else we want to say about it. Let's talk about that 100%. So this represents 100% of my data. So that means that if I take this guy and I divide him in half, that means that 50% is above up here, and that means that 50% is below down there. So normal distribution curve, when you're standardized, that's the cool part about it. Now, let me add something to that. So in high school, you took the ACTs and the SATs. And let's just use this next curve since it's clean. So let's say you took the SATs and the ACTs, and let's just say that just for reference, the highest score you can make on the SAT was 800, and I think now it's 1600. It changes around, so I don't know for sure. And the highest ACT is 32. Well, you took the score, you took the test, and out of 800, let's say you scored 625. So you took the ACTs, just kind of see if you maybe do better, because you heard it was a slightly different test, and let's just say you made a 23. And so you're trying to establish like which one you did better on, because obviously it's hard to compare and say, well, relatively, which one did I do better on? Well, that's what z-scores are for. So that's what a z-score does for us, and that's when you take your data and you standardize it and put it into this situation, you can compare z-scores and see. So we come back to this slide, and one thing we need to know, a couple things. We need to know, first of all, is that at this point, to be able to move forward, to be able to standardize it, we have to know the mean and we have to know the standard deviation. So to be able to do that, we'd have to know our mean and our standard deviation for each set. But the cool part about it is that once you know those, then you can just plop those into your z-score formula, and like bam, you got your standardized score. And what that standardized score does for you is it allows you to place yourself. It allows you to say, oh, you know, 2.25, I am well above the mean, right? Because this is like the mean right here. So if you're 2.25, you're well above the mean. If you're negative 1.5, you're well below the mean. So you kind of get that idea of placement, just standardize. You're standardizing your score. That's why it's called a standardized score. Alright, so in the video, in the video the girl talks about, from Hawks, she talks about like being given the mean and standard deviation and plotting it. And so at this point, I just want to run through like how she builds it to kind of give you a better explanation, but it just ties in. So hypothetical, making numbers up. So let's say we have a data set, and the mean of our data set is, for the ease of conversation, is 50. And let's say that our standard deviation is 5. Okay, so when we come to our data set down here, we're going to plot a normal distribution. Remember, our mean always goes right smack in the middle, so our mean is equal to 50. If we go up, that's 1 standard deviation. So remember, that's going to be your mean plus 1 standard deviation. So that's going to be 50 plus 5, which means that data value is 55. The next one would be the mean plus 2 standard deviations. So that would be 50 plus 2 times 5, and that would be equal to 60. You go up again, that would be the mean plus 3 standard deviations. So that would be 50 plus 3 times 5, and that would be 65. So that would give us our data, these fixed values. These are like landmarks to me. Like these are like, okay, well if I'm 1 standard deviation above, I'm a 55. If I'm 2 standard deviations above, I'm a 60. And if I'm 3 standard deviations, I'm a 65. If I go the other way, that would be my mean minus 1 standard deviation. So that would be 50 minus 5, which would be 45. If I went again, that would be the mean minus 2 standard deviations. So that would be 50 minus 2 times 5, which would be equal to 40. And then the last one would be the mean minus 3 standard deviations, which would be 50 minus 3 times 5, which would be equal to 35. So once again, these are like my landmarks going down. So it's like if I'm 1 standard deviation below, I'm at 45 compared to 50. 2 standard deviations, I'm at 40 compared to 50, and 3, and so forth. So normal distribution, being able to build this and then kind of talk about you know, what it means. Now there's more to this, and we need to add the empirical rule, but we'll wait until they're ready for us. This should get you through the homework assignment for 6.1.